Thank you. Yeah, hi everyone. I'm Aaron, and I'm here to talk to you about customer Keynote from NASCOP in Kenya. Okay, so what is NASCOP? NASCOP stands for National AIDS and Sexually Transmitted Disease Control Program. It's the department of the Ministry of Health in Kenya. So this work, I have to acknowledge, first of all, the leadership at NASCOP for allowing us to do this. And also PSK, I do this work as a consultant for them. And there are many other non-for-profits also working with NASCOP to fight HIV and AIDS. Okay, now, as Bill Clinton was coming out of office in the early 2000s, he wanted to do something about HIV and AIDS. People were dying, drugs existed, ARVs existed, antiretrovirals, but people were dying because these drugs were unaffordable. So what he did is he got involved in some fundraising, and they managed to reduce the cost of these drugs by purchasing generics in massive volume. So basically, you do one order for the whole country, and that's a game changer in terms of the price of these drugs. So now drugs were available at a national level. So we could see drugs coming into the country. I'm just giving a bit of background, by the way. We could see drugs coming into the country, but we were still seeing shortages at a facility level. And now shortages of ARVs is a serious problem because the ARVs only work effectively when they are used consistently. I mean, you have to use it at the same time every day. You have to be healthy. You have to do exercise. You have to see your clinician. So shortages is a serious problem. It would stop the drugs from working. So the solution to deal with these shortages was to set up a commodities system. Now, the commodity system was an offline, it's a Java application that can run on any form factor, PC, tablet. It can be offline or online. And this helped NASCOP to collect usage data. Okay, now from this usage data, a commodities dashboard was created. And from this dashboard, we could now identify and deal with shortages. Okay. Now, we had reduced the cost of ARVs. We have these drugs now available on the ground. Now, the next problem was people are taking medication, but they don't know if the medication is working or not. Yeah, we call this, there was a total lack of visibility in terms of patient outcomes. In fact, we had people taking these drugs, and they were not getting better, they were getting worse. So the solution to that problem was to set up labs to measure viral counts so that we could track the way the virus was evolving in each patient. The equipment that was used to measure viral counts was placed in these 10 facilities around the country. It was not purchased, it was sort of leased. And the payment model for this was on a per-use basis. And this allowed, so this ensured that the equipment manufacturers had to ensure that the equipment was working, because that's the only way they could get paid. And then the NASCOP was tasked with making sure that they could generate enough demand so that this equipment is used at the highest possible utilization. Okay, so now we knew the patient, you could measure your outcome to know if the drugs are effective. The next problem is that the labs themselves became a bottleneck. If you have HIV, you need to get tested at least once a year. So there was a lot of inefficiencies in these labs. So basically, there was no system at the labs. A lot of metadata had to be entered for each sample, for each individual. So it was really time-consuming. So you could send a sample in for testing, and it would take months before you got your results. So what was needed was a lab system, and I'll talk a bit about that lab system later. And then finally, we also didn't have a national dashboard because it's basically it's a public health is a data-driven activity, and without a national dashboard, you basically can't make any good decisions. Okay, let me just dive right into the solution. So there were two parts to this solution. One solution was for the labs, which was a lab information system. And this lab information system is basically, it was based on NGINX, both as a reverse proxy and a web server. Now, the lab, there were many choices we had about regarding the lab system. We could either put the lab system in the cloud, we could put the lab system at the NASCOP data center, or we could do it on-prem. The decision we made was to get a single box on-prem. Now that box, depending on the lab, some labs were comfortable with Windows, other labs were more comfortable with ESXi, other labs were more comfortable with bare metal. So we actually have a mix of these different types of installation depending on the skill level and the comfort at each lab. On this box, we ended up doing a single node Kubernetes cluster. Yes, that's true. You heard it right. Single node Kubernetes cluster. You shouldn't try that. Yeah, I mean, there were budget constraints. It would have been lovely to have put a high availability box or storage and multiple hardware servers at each lab, but funding just wasn't there. So we just had to go with a single box. On that box, we put Kubernetes and Docker for containerization and orchestration. The app server was basically Laravel, which is a PHP framework, with Redis for the message bus and caching. And then we also had NGINX Plus for the web serving as a container. And then on the same box, we set up a MySQL Enterprise installed on the bare metal, not as a container. And again, I said the reverse proxy was on that same box. So all we could do in that lab, we only had 1 U of space in that data center. So we had to cram everything in that single U, all the stuff that we needed. Now, since we had just a single server at each lab, of course, disaster recovery and continuity is now critical. So we had a VPN solution so that we can replicate data in real time back to the DR sites and to national. And we also, for us to manage these remote sites through that same VPN, and also because of the security, since we are dealing with medical data. All the code and configurations were stored in Git repositories, although we didn't go full cycle in terms of pipelining. Now, this solution, as simple as it looks, it's actually quite simple. It's a very simple app. But it was a game changer for these guys, because all of a sudden, those remote facilities, and these facilities, there could be about 2,000 facilities around the world, around in Kenya, being served by 10 labs. You can imagine 2,000 to 10, some of the facilities in really remote locations. But each facility could now do what we call remote login. So they could log into the lab system and directly enter in their own metadata. That means when the sample gets to the lab, there's no need to have a data clerk to re-enter that data. And that really changed the lives of those labs. We also set up some APIs so that we could do programmatic data entry and result retrieval. Some of the facilities are really sophisticated. We have a mix. Some guys had their own apps. Some people had their own EMRs, so they wanted to exchange data from the hospital system to the labs programmatically, so we could do that. We made sure that all the labs, the 10 labs with all these differences, had the same code base, and we encapsulated all the differences in environment variables. So we just have one neat code base, and as we change from one lab to the other, it's just a change of a couple. It's just a simple 10-line config file that we need to change, and we spin up a new lab. Now, as a result, all the results could be obtained by web. You could get them by email. You could get them by text message, and they were also printed and couriered back to the original facility. So for us, really, the most important thing was when you go to see your clinician and you have HIV, all he needed to do was pull out a simple featureless phone and a couple of quick queries on the phone, and he could tell you what your viral count was and give you that result instantly and appropriately without waiting for you to go and come back. And that really was a big game changer. At the national level, what we had is it was bigger. We threw a lot of money here. I know there are some Dell guys around, so I was telling them I'm a Dell customer. We invested in a VX block, Dell EMC, really expensive piece of metal. So massive. Actually, I worry about what we are going to do with it when it's time to bring it end of life. It might cost us more to get rid of it than to buy it. But anyway, then we were secured with edge and internal hardware firewalls, and we also have F5. And then we did NGINX Plus, as I mentioned, and MySQL Enterprise, and we leveraged as much open source as possible. Of course, we cannot forget Microsoft and Windows. There's Microsoft and Windows all over because of ease of use, but we didn't put that anywhere. And then, so in terms of the actual solution, at the national, we were able to do a multi-node Kubernetes cluster based on virtual machines. Again, the same kind of containers, Redis, Laravel, NGINX Plus, and we also had the MySQL router. We were using, because we had the MySQL router, because we were using the MySQL Enterprise cluster. I don't know if any people are using that here. It's an Oracle solution for MySQL. So we had a MySQL cluster just to make sure that we don't lose data in the event of a hostile reboot. We also managed to deploy Prometheus for monitoring the container environment. And we also had the NGINX controller, as mentioned before. So once, basically we took advantage of all that lab data to create a national dashboard. And this was also very important. Because once we have all that lab data, it was very easy to build up. I mean, all the people are getting themselves tested at just these 10 labs. If we can get all that data from those 10 labs back to national, then we have a complete picture of what's happening with HIV and AIDS in the whole country. And that's what we used to create the national dashboard. It was a good, a pleasant kind of surprise or result of having done the hard work of setting up a lab system. So now, with that, on that national dashboard, we could identify slow labs. So if a lab had a problem, we could move samples from one lab to another. We could identify problematic facilities. If you had a facilities where people are not being advised the right way, we could see. You could trend, hey, this facility, they have like 80% of the people, only 80% of the people are not going from HIV to AIDS. And nationally, it's 90. So you could identify that particular facility and maybe do something to help them. We could identify non-performing ARVs. We could see this kind of ARV in this region is not working. We could identify terrible sample types. You could tell if we take dry blood samples and use that for measuring HIV, the results are not as good as getting blood serum. So behind the scenes, there's actually people shipping blood all over the country. And then we were able to avail this data. We had all the data open. So researchers can log in, partners can log in, and everyone can see the data that we have there. So in fact, whenever these performance reviews are done, there's no need of bringing anything else. All the information you need to do to have a performance review was actually just availed directly on the dashboard. Now, what are the benefits I've said? High availability, high availability nationally, and faster disaster recovery. So like I said, nationally we had a VX block that has been very reliable, but at the labs with a single server, we experienced a lot of failure. It was some HP servers, and in fact, right now I have 2 of them down, and they're running from the disaster recovery side. But the beauty of having everything on Kubernetes is that it would take me like half an hour to spin up I have to actually spin it up from scratch. I have the database, but you could spin up a lab in 30 minutes at the disaster recovery site. Since it's 30, and that is within the accepted SLA, by the way. 30 minutes might sound by a lot, but it's OK for us. We had we reduced the turnaround time in the lab to about 10 days. At the beginning, we could see samples lagging in the lab for 30 days or 45 days. Imagine you sent in a sample to check what your level of HIV or viral load count is, and it takes 45 days to get the results back. We reduced that to 10 days on average, and the different labs can actually compare and see how they are performing in real time. It's on the dashboard. We are now doing about 3,000 samples a day in all the labs, which isn't bad. And then basically this dashboard enabled government to be able to do this public health thing. Then what's next for us? We want to go to pipelining, of course. And then for me, really, and here is where I'm looking to the what did you guys say? The excellent engineers in the audience here. I'm looking for help to take this project, to create an open source project out of this, to ease distribution of this project. So if there are any guys who know how to do that, please reach out. Already we've managed to, Ivory Coast took it, Uganda's taken it, Malawi's taken it, Cameroon's looking into it, and we give this whole code base to them for free. So whoever wants to have a dashboard, whoever wants to have a lab management system based on HIV, they just reach out to NASCOP and they can get the code base, and they can even get assisted in terms of setting it up. But we would like to make that less tedious. The guys from Ivory Coast, they speak French. They have translated the project to French already. Yeah. So finally, I just wanted to say a few things in this project. I really struggled with, I'm using the Kubernetes ingress controller on NGINX. I'm actually using it on NGINX open source. I wanted to use it on NGINX Plus, but it was quite a difficult thing to do. Maybe it's improved now. I was doing this, 6 months ago. I ended up doing it using Helm, but there are so many different ways of doing it. Sometimes you wish you could just have one clear guide so that you don't have to suffer doing things over and over again. I had hoped, I'm also using the NGINX controller, which for me is brilliant. Although I'm comfortable with command line, the other members of the team would rather do things graphically. And so rather than me becoming a single point of failure, I want to open this thing out so that other people can use and manage this thing rather than me. But the controller, one of the limitations for me in terms of the controller was that it doesn't, they've told me it's coming. When you add an instance of NGINX to the controller, the configurations, and you need to redo the configurations in controller language so that you can manage, or you can push configs the other way after that. So when we get to that stage, and I think that's when I will start using the controller really. So right now, I just use it for monitoring, not really for pushing configs. I've also said this many times. I wish the controller was more like, I was hoping that the controller could be more like the Oracle MySQL Enterprise Manager, the EMM. I don't know if any of you have seen it. That really gives a lot of advice, like, wow, you've got too little memory, you've got too little, I mean, all the tweaks that you need to do are actually just, you're just told, do this. And that's the kind of thing that I was hoping the controller could do for me, because NGINX has so many configurations. I don't know all of them. I don't really understand all of them. I consider myself a script kiddie, not really an expert. So I was hoping that rather than sending an email to Plus Support, which is amazingly fantastic, those guys are so fast and they explain everything. It would be nice to kind of get that sort of guidance from the controller. So we're still waiting for that to come. I also found that doing Kubernetes on bare metal, that is quite rough. My feeling is, after moving around with this Kubernetes thing, is, OK, at the time, it's like a cloud thing. It's something for AWS. It's something for Azure. Maybe it's not for us. that window, that support matrix window is moving so fast. You have to keep updating just to make sure that everything is within the supported matrix. So, but we still decided to do it because we need to be cloud ready. Like I said, I don't know if that data center is still going to be there in the next 2 years. And at that point, we need to ready ourselves to move to the cloud. So that's why we are investing in doing the Kubernetes at the lab and also at national. In terms of DR, I also found the MySQL replication. I use MySQL replication, yeah, which is quite nice. It breaks, but that's why I have the enterprise manager, which lets me know when things have a problem. So yeah, I think that's it for me. So it was a very good project to get involved in. Like I said, for us, in terms of, and he mentioned it, it's about lives. So it's not really about money. And the labs work on a batch process, so you can afford a little bit of downtime, but not more than half an hour, not more than an hour. And that's where the project is. So that's it for me. Hey, if you have any advice or if you want to tell me anything, just reach out. You'll catch me in the next room. So thank you very much for your attention. And that's it for me. Rob?